Hi folks, Mr. Nickel here. I'm just going to give you a quick video tutorial on how to number the parent chain of a cycloalkane when it has a functional group or a substituent. I realize this could be a bit of a confusing topic, so let's go into some of the ideas. And so when we're looking at this molecule just like this, it can be a little bit confusing as to what number do we have. When we don't have any substituents on it, it doesn't matter what carbon you put as number 1, you can put any of them as number 1 and that'll be accurate. It's as soon as we start getting substituents on here that changes. So now you can see I've added this functional group here. So we've got our cyclohexane, our base cyclohexane there of 6 carbons, and you can see that on the top I've added 2 carbons there. And so if we've added 2 carbons, that means that we've added an ethyl group. Eth is our prefix for 2 carbons. And so what that means is this is going to change how we actually number our cyclohexane now. So rather than having it be any one of these ones be okay to be number 1, now it has to be this carbon right here. Now the interesting thing is we don't start up here. And the reason is that we want this functional group, the cyclohexane here, to be at carbon number 1, so that we don't have to give it 2 functional groups, we just have to give it 1. And so what we'll see here is that we'll start here 1, and it doesn't matter if you go clockwise or counterclockwise, either of those are okay. But what does matter is that you label this ethyl group here. So this would be carbon 1, one of these 2 here would be carbon 2, and then 3, 4, 5, 6, it doesn't really matter which direction you go after that. But that means that this ethyl group here is going to be on carbon number 1, which means that when we're naming it, we don't have to put the 1 in front. So this could then just be ethyl cyclohexane, and that's our final name. Just for your information here, now you can see what ethyl cyclohexane looks like in 2 dimensions as well as 3.